Yeah, it's really loud. Okay, so this is the mic as well. So, chapter 4.1, as I said, the day that the assignment is due, we are going to go full force into the next chapter. I'm going to give you a bit of a rundown of what we've done so far and where we are going for the last chapter of what I call polynomials. Rejoice if this is up your alley. After chapter 4, 5 and 6 goes into trigonometry. So SOHCAHTOA, the triangle stuff, sine law, cosine law, and this stuff too, like roller coaster with functions. Okay, it's going to be pretty interesting, I think. Chapter 4 and 5, 6, 7, and then 8, we start dabbling into, it's leading us up into what I consider to be the most fun chapter, and that involves things like investments and money, money math, I guess, in chapter 8. Okay, so hang in there. Chapter 4, though, is going to be very mechanically heavy. There isn't anything I can assign to you as a project. This chapter, our final evaluation is going to be in the form of a test. Okay, so what are we doing in chapter 4.1? 4.1, let's go back. I'm going to read this here. Chapter 2 and 3 explored a lot of different things. Let me remind you, chapter 2 was all about the factoring because this part was such an important piece of your grade 10 and, well, grade 11. It'll be important for grade 12. It'll be important, so on and so forth. So this was chapter 2. Chapter 3 used your knowledge of factoring to get an equation and then use it to get x-intercepts, use that to get the axis of symmetry, and use that to get the vertex. And so you can use that to, bam, bam, vertex, bam, axis of symmetry, bam, and then you were able to draw a graph. Everyone following so far? You may not quite, I don't know how much you remember of actually how to calculate it, but I'm hoping you recognize all of these things just from your assignment that you've done for me. Chapter 4 is going to do two different things. Chapter 4.2 is, and 4.2 is going to focus on this shortcut. Take a look at what we've done. All of chapter 2 and 3 was needed to follow along this flow chart. If I give you an equation, you factor from chapter 2 to get a factored form. And you use it for the x-intercepts, for the axis of symmetry, and for the vertex. And if you remember, going back to even chapter 1, that vertex can be used to give you an equation in vertex form. You remember that from your assignment, the H and the K? You have to do all of this just to get to vertex form. Chapter 4 is going to give you a shortcut where you can bypass all this if you wanted to, but it requires some very heavy mechanical, mathematical work for this shortcut. This thing we're going to look at tomorrow is called completing the square. 4.3 and 4.4 are going to also give you a kind of shortcut so you can identify situations. What if that wasn't allowed? What if there was an equation that you couldn't factor, but you still have to find the x-intercepts? This is what I mean by not factorable. I'll give you another strategy. Long story short, chapter 4 is going to focus on the vertex form. Before we were focusing on the factor form, chapter 4 is the vertex form. And so today's lesson, I'm going to try to refresh your memories on what you can do with vertex form, why it's so important, and why it's so helpful. If you don't appreciate the vertex form, then what's the point of doing it, right? So I'm going to try to show you why this is useful. And then tomorrow we'll look for the shortcut. My final goal for today, at the very last page, is for you to be able to, for you to take an equation, automatically figure out the vertex, figure out the axis of symmetry, figure out whether it opens up and down, sketch it very, very briefly, very, very roughly, and tell me what the range might be. So I'm going to do some of these questions with you as an example so that you won't feel lost. Any questions on where we're headed? Okay. So goal of today, why am I focusing on the vertex form? Why is vertex form useful? Okay, that's my lesson today. Here we go. The following demonstrates the usefulness of an equation in vertex form. If you remember, in chapter 1, we looked at how transformations can be performed on y equals x squared, right? That turned into this. We have, I guess I could color coordinate this, a reflection on the y-axis right here, as well as whether it's a vertical stretch or compression. The h value, the horizontal shift, by whatever number that is, and I'll use green, k is a vertical shift, and it represents that. That was chapter 1. We did a big chunk on transformations for chapter 1. If we understand this, I'd like you to think about this portion right here, these 2 points. This has to be very logically understandable. Did you read this little bullet right here? Okay. Horizontal shift by a certain amount, vertical shift by a certain amount. If you know what h and k is, you know where the vertex 0, 0 went. Yes? Pardon? I do think this was left by, might want to sharpen it, but there's a sharpener behind Jessica. I mean, Jennifer. So just from knowing A, H, and K, you can pull out a lot of information. So let's do it. Everything from now on is going to be based on what you can find just from A, H, and K. Every single time I'm going to be looking at these 3 numbers and try to pull information out of it, try to analyze. Okay, here we go. Just from knowing A, H, and K, I can identify the vertex. Sorry, well, that was obvious, I suppose. I didn't even write that in. Yes, immediately identify the vertex. How about I do an example? So as an example, my example every single time is going to be negative x plus 1 squared minus 5. If I know that this is going to be my equation, should I write this more clearly? I'll write it more clearly. Let's say, for example, I have a function. I give you the function negative x plus 1 squared minus 5. Because I know this is a plus 1 and that's a minus 5, my vertex is going to be negative 1, negative 5. Right away. Again, I hope that's not something you memorized, even though you could, but you realize that because the vertex that used to be 0, 0, it has now shifted 1 to the right and 5 down. My vertex is now here. So those two numbers tell you the vertex right away. Let's move on. Number 2, if you know where the vertex is, you also know where the axis of symmetry is. Take a look at H. Start right here. Just from that, the H of the vertex is the axis of symmetry. Therefore, axis of symmetry, x will be equal to -1 right away. No calculations, you just know it's -1 because the vertex is at -1. Number 3, you can immediately identify whether it's opening up or opening down. As you know, parabolas can do this or parabolas can do this. How do we know? Well, normally it opens upwards like that. However, if you see the f of x have, or the function have a negative a value, it could be a -1, -2, -0.5, it doesn't matter. If you see a negative, the function, the parabola, is opening downwards. Right? So therefore, it's opening downwards. It is this one, it's not that one because of that negative. So up to now, everything I've just talked about has nothing to do with actual calculations. It's looking at an equation and pulling pieces out of it. Any questions from that? It's very, very, very important. You look at H, K, and A, and you can automatically tell 3 very important pieces of information. The next page is going to be some calculations, right? So here's what we can find if we, flex a little bit of our brains. Here we go. Moving to the next stage, you good? Yeah. You sure? Okay. I saw you were like focusing. I thought you were looking at something else. Here we go. For number 4, oh, wait. Yes. Right. Number 4. Oh, it goes straight to the next page, doesn't it? If I could give myself some space. Nope. Okay. Number 4. If you wanted to find f of x in standard form, because let's say you wanted to try factoring or whatever, you can still do that. How? Let's expand. I'm going to write this out. F of x is equal to -1 x plus 1 squared, right? So it's just x plus 1 multiplied by itself minus 5. Let's multiply it out. I am actually going to leave a negative and multiply the 2 binomials and get that out of the way first, because I think that might be the most challenging. We have x times x, x squared, x times 1, and 1 times x. Together, that's going to be 2x. And then 1 times 1 is plus 1. Let's keep expanding. Now, it's funny. I'm actually, we just got into the lesson for learning, for expanding with my grade 9s for the first time. They're struggling, but they're keeping up. So if you want to get rid of the brackets, we'll take a look if there's any numbers in front. We're going to distributive property, multiply that number in. This becomes -x squared. This becomes -2x. This becomes -1. And the -5 is still there. And if I simplify by grouping like terms, the only like terms I see is the 1 and the -5. -1 and -5. So my final equation is going to be -x squared, -2x minus 6. This is standard form. right? So you can say that A is -1, B is -2, C is -6. That's it. All right. You can do a couple of other things. What are some important parts of a graph? Well, x-intercepts, y-intercepts are just as important as the vertex when we're talking about, when we apply this in word problems. Like if we were talking about a rocket or a cannon or an arrow or a football, whatever is being thrown, the catapult assignment, we were interested in when the catapult lands on the ground, right? Those are x-intercepts. Things like that become very important in word problems. So it would be nice if we can use the vertex form to calculate x and y intercepts. So again, you can still calculate the x-intercept if you set the y value to a 0. So if the entire function is equal to a 0, solve for x. We're going to have to do some isolation. And surprise, again, my grade 9 is learning that for the first time right now. It's pretty funny how we're using it to sort of like, without thinking about it, right? We have to use isolation and stuff without thinking about it. 2 years ago, and you might have been the first time you've seen it. So let's try it. I want x all alone. This is my goal. So I am going to do the inverse operations, the opposite operations. And we're going to do BEDMAS in reverse order. I want to get rid of a -5, so I'm going to add 5 on both sides. All right. So now I have 5 equals -x plus 1 squared. Now I want the -1 out of the way because I have to get rid of that before I can get rid of the exponent. This -1 is multiplying, so the opposite of multiplication, division. I'm going to divide both sides by -1. Okay. I'm working from the outside in. Welcome. Now, if I want to get into the x variable, sometimes I always feel like I'm sort of like I'm cracking a nut and trying to get into the inside. I need to get rid of the x squared. Sorry, I need to get rid of the square. The inverse of a square root. So I need to square root both sides. Interesting. I don't even know. Okay. And I could go further, right? I want to get x all alone. Let's say you don't catch this, but let's say, you want to go further. I'm going to subtract both sides by 1, so it becomes this. But some of you might have seen something. Some of you might have said, oh, you don't even need to do that, Mr. Kim. You got to stop. Something's wrong. Do you see something wrong with this line? If there was nothing wrong with this line, then yes, you're supposed to subtract by 1 and you get x equals square root of something minus 1. You could plug that into the calculator to find what that value is. Anything wrong with that one? No, there is something really, really problematic. The inside of a square root is negative. Can't have that actually. So you say this. You cannot square root a negative number. Therefore, no x exists. Sorry, how about no x works? No x value works. Therefore, no x-intercept. I do want to move on, but stopping right there, how is that possible? How could a parabola not have an x-intercept? Doesn't it always have an x-intercept? Doesn't it always have an x-intercept? Be creative. How could I draw this so that there is no x-intercept? Yeah? Like it's underneath here. Ah, yeah, like that. A parabola is not touching the x-axis. So it is possible that you cannot have an x-intercept. Good thinking. So math don't lie, okay? Doesn't have x-intercept. We can also calculate the y-intercept by setting the x value as 0. So what is f of 0? Negative 0 plus 1 squared minus 5 equals negative 1 squared minus 5 equals negative 1 minus 5 equals negative 6. I will give a quick second. And after you copy all that, there is enough information in the front, the previous 2 pages to get you to try to roughly sketch a graph in number 7. I'm going to give you a couple of minutes. See if you can piece that information together from numbers 2, 3, 4, 5, and 6 to roughly sketch a graph in number 7. To prove to yourself that yes, you can still sketch a graph with just the vertex form equation. You don't need the x-intercepts. Because chapter 3, you always needed the x-intercepts. In fact, you don't quite need it. See if you can do it roughly. I will pause the video. So loud. Okay, let's do it. Here is what we can establish. Number 1, do we know where the vertex is? Yes. Yes, we do. We knew from number 1, it was negative 1 and negative 5. So you should have drawn your vertex somewhere here. That is negative 1 and negative 5. That's the vertex. Number 2, I know there's an axis of symmetry, and that I will draw in light colors right here. I'm drawing this even though I know the vertex because it will give me like a mirror. In my head, I'd be able to draw a mirror right there. I know the left side and the right side of that dotted line is symmetrical. Number 3, identify the parabola opening up or down. We established that it was going to be opening downward somewhere. I just don't know where. Number 4, polynomial, sure. Number 5, there are no x-intercepts. That makes sense. It doesn't hit any of these points. Number 6, my y-intercept was negative 6. So 0, negative 6. It's going to hit here. But backtrack to the green dotted line. If I have a point here, then I know I'm going to have a point right there because it's symmetrical. And that's all I have. But do I have enough points, or do you have enough points to vaguely sketch your graph? I think so, right? So the vertex form of an equation helps a lot, right? There's a lot of information you can gather from just one equation. Something like that. And of course, if you have all this information, you can use it to, solve word problems as well. But that's like 2-3 steps from where we are right now. My goal for you, my task for you, and we're going to do this together, is to be able to look at an equation and pull all that information out quickly. Because remember, if I give you this on a test, it's not going to be like, here's one question, you have 30 minutes to do it. It's like, here's one question, you've got like 5 to 10 minutes, right? So let's try this question. Let's try some of these practice questions together as practice. And your goal will be to get faster and faster and faster. All right. Number 2 is what I wanted to start with. Maybe we'll cover number 1. Please note, what we're doing here in number 1 is essentially what you were supposed to do as a thinking question in your assignment. Dun, dun, dun. Okay. Catapult assignment would have had something like this already. So I'm going to leave that alone for now. Maybe talk a little bit more tomorrow. Let's do the bare bones here. You can either sketch on a separate piece of paper. You can use the little sticky pad with the grid on it if you want, if it helps you for your homework. But for the limited amount of time and space I have on this video, I hope you will forgive me for sketching it very briefly here. All right? Function. Here we go. X minus 3 is squared plus 1. What's the vertex? I will do this one for you. These 2 numbers tell me what the vertex is. You can't really see that, so let me do that in red. These 2 numbers are so important for the vertex. The vertex is 3, 1. And if you know the vertex, you automatically know the axis of symmetry. What is the equation for the axis of symmetry? Go ahead. Yeah, because it's right there, right? X equals 3. Next, now that we pulled some information out from H and K, let's look at A. Does it open up or does it open down? Pardon? I thought I heard it. Yeah, absolutely. The A value in front of that bracket is a positive, so I know it's going to open up. Yes? Yes, go ahead. And before I talk about the range, because I didn't give you an example of a range, let's quickly sketch it just from this. Very quick sketch. My vertex is going to be x equals 3, y equals 1. It's going to be there. And it's opening up, so it's going to look something like this. I don't know what the A value is. Well, it's a 1. I do know it. But I'm not interested in that right now. I want to see the range. By quickly sketching it, I have an idea of how high or how low it goes. What is the range of this parabola? Oof. By range, I mean, what are the y values that are allowed? How high does the y value go? Go ahead, Cameron. Correct. So it goes up to infinity. How low does it go? 2. Not 3, that's the x value. How low does it go? 1. So the range has to be, y is going to be greater than or equal to a 1. Remember these symbols? All the way back in chapter 1.1 and
1.6 or something. So there's my sketch. I'm going to call this sketch number 1. Yeah, I'm going to draw that here. Go ahead and match. And that's it. Just from the vertex form, you can pull out all that information. Let's try it one more time. Let's do a slightly harder one. There's a fraction here, but I don't want you to get scared. Let's do D. Once again, looking at these numbers, you can automatically figure out what the vertex is. Someone else? Someone else? Someone else? Washroom?
No, I was just gonna ask, do we have to do the sketch part of it?
I think unless you're very savvy with the range, if you can figure out what the range is just from looking at the vertex and opening, I recommend doing the sketch first. But again, if you are savvy, then just go for it. It's up to you. I'm just afraid that, you know, there might be some careless errors, that's all. So again, let's do this last one together. The H is well, it looks like in the equation, it looks like a +5, and then the last number is a +2. So what's the actual vertex? Someone else? Jay? Pardon? Close. Take a look at the first example. It was a -3 and we wrote a positive. Remember that part? So in this case, it would be -5, no, just that one. The last number. Inside the bracket, the H value, think about it this way. It always starts with a negative. So if the negative H is a -3, that means I'm subtracting a +3. If a negative H is +5, that means I'm subtracting a -5. It's sort of like that. You try to review it. We did talk about this earlier in chapter 1 too, but people probably forgot. If the vertex is at -5 and 2, the axis of symmetry must be at -5. Take a look at the A value now for opening. It's a -3, so it must be opening down. And using this information, I am going to quickly sketch. So I'm going to call this number 4 in my homework page, because it's D. My vertex is -5, 1, 2, 3, 4, 5 to the left, and 2 up. There's my vertex, and it's going to be opening downwards very, very fast. Remember, this is just a very quick sketch. Doesn't have to be super accurate for now. The only way you want to be more accurate is if you have x-intercepts and y-intercepts. But anyways, if this is the case, I see that I am going down to -infinity forever and ever and ever. But there is a limit to how high I can go. There's a roof here. That is a 2. So y is going to be smaller than or equal to a 2. And that's it, everyone. This is 4.1. As I said before, the goal of today's lesson is to appreciate the vertex form, that you know it's useful, that you can pull a lot of information from it. And so if you believe that, tomorrow's lesson will be like, okay, well, what if you have a situation where you don't have vertex form? Let's get vertex form. That's tomorrow. Okay, so let's try to appreciate the vertex form. Do number 2. See if you can actually you know what? Yeah. Since your project, your catapult assignment is out of the way, after you do number 2, see if you go back to do number 1 and even number 7, because that's an application question. Remember, for chapter 4, our final evaluation is a test. Okay? I can't do these skill sets using just projects this time, at least in my head. Okay, so do your best. Please do some of the homework. At least try to fill this chart in before you go today. You still have about a good 25 minutes or so. ask me questions. If you still haven't done your catapult assignment, of course, that's very, very important. Plan your time wisely, and we'll reconvene tomorrow.